Hello, my name is Bryce, Bandman444 on the Rocketry Forum. I'm going to show you what method I use to attach aluminum fins to, in this case, a blue tube airframe. So the aluminum fins I machined myself. The three that are going to be used in this video are the pre-production pieces, I guess. And so they do have some flaws that have already been addressed and taken care of. The first step is marking off where on the tube the fins are going to go. The easiest way to do that, the way I do it, is I attach the first fin. Since they're surface mounted, I don't need to worry about slots or anything. But it doesn't really matter where I put it, because all the other two fins will be based off that one. And so what I'll do is I put the first fin on completely, and then I'm going to take a sheet of paper and wrap it all the way around. Okay. Wrap it all the way around till where they touch. I'll put a mark in between there, and that's the circumference of the tube. And once I get the circumference, in this case it was 9 3/4, a hair over 3/4, but pretty close. You divide that by 3 for 3 fins, 4 for 4 fins, and in this case it's 3 1/4. And then I'll mark off, I don't know if this shows up, but each of those 3 points where the fins will be located. And what that means is when you wrap it over on top of each other, okay, you know exactly where the center of each fin will be. And so once you get this all lined up, when the paper meets itself, you know that you're perfectly in line with the tube, so you can go ahead and draw a horizontal line, noting where the top of the fin is going to go. And then also each of the 120-degree points on the thing, on the tube. And so I've already done that here. I just used some pen that I had around and marked off where each of the fins are going to go at exactly 120 degrees. Once I did that, I took the fin, and it hasn't been sanded at all, and neither has the body tube, and I put the fin on where I put the mark. And for these fins, because, I don't know if this will show up, they have a radius here that perfectly matches the radius on the tube. And so once you put it on, there's no worrying about whether it's cockeyed or anything. They lay flat on the tube exactly in the center. And so when you put it on, and I'll match it up with the line I just drew, then what I do is I take a pen and I really quickly just get a rough idea of the entire outside here of the fin, just so I know kind of what area is going to be bonded. Well, I tend to go over the lines with the sanding because you can always sand away or, get the better finish later. Not really a finisher painter person, more of a, just kind of want to get it done and do it well. So once you do that, we're going to first start by sanding the surface of the airframe. I'm going to use 60 grit sandpaper. I like to just take a little 1.5-inch square piece, maybe 2-inch square piece, and go ahead and just, really rough it up. I also like to go in multiple angles, try and get as much, grip as possible. Okay, and so that's pretty good with the 60 grit, but for added adhesion, I found that just using an X-Acto knife or any kind of sharp instrument to really cut hash marks into the airframe, pretty deep. You're not wanting, don't be a girl about it, but you kind of just want to etch. I do it in one direction, one way, make sure you're covering the whole area here. Okay, and then I'd come back and I do it the other way. We're wearing safety glasses here. And then I come back and I do it the other way. I'm not super neat on exactly, making everything line up. The lines will go off the edge, but I'm more worried about the adhesion portion rather than the appearance of this rocket, or most any of my rockets. Okay, so now you have a big checkered pattern, and then I kind of, really want to get as much of the deep gashes. This kind of lets the epoxy really get into the tube, bond to more than just the surface layer, especially on filament wound fiberglass or carbon fiber. Our Project 60K project had an issue with being able to bond just to the outer layer. So hopefully this, the blue tube even has an added benefit in that it's one single layer on the outside. And once I do that, I tend to take a paper towel. Sometimes I'll soak it in, some rubbing alcohol or something, just to get the grit out of, you're not trying to bond to the sanding. You want to actually bond to deep in the tube. So that looks really good. Now what we're going to do is mix the epoxy. That is not as much fun as it sounds. I love using 5-minute and 30-minute, but for this we're going to be using Loctite Hysol 9430 epoxy. And the reason it's not very much fun is that the hardener here is thinner than water, and the resin is thicker than anything that I've ever tried mixing with something thinner than water. And so it kind of tends to be a little difficult to weigh, because this epoxy measures in 22 by 100, 23, sorry, to 100 parts. And we're going to make what I would do is like a 10th batch, so we'll use 10 grams of the resin and then 2.3 grams of the hardener. We want to start with the resin first because that is the harder one to measure. It's much thicker than syrup and doesn't want to be measured at all, really. But what I do is I'm going to take a couple popsicle sticks, put them around here somewhere. Oh, here they are. Okay, a couple popsicle sticks. We'll set up the scale here. I'm using just a paper cup here to mix everything in. And we'll turn on my Harbor Freight scale. And we'll see what we can get here. Again, I hate, before working with epoxy, it's super important. You always want to put on gloves. These are, I think, 3mm nitrile gloves. And I'm always wearing eye protection. So far, I guess I haven't worked with it enough to be allergic or, have any kind of allergies to the epoxy. But too much exposure and that kind of stuff. You don't want to be breathing in this epoxy either. The hardener especially has an incredibly strong odor that does not smell very safe for you. So wearing gloves will kind of stick it on here. Let's see. Okay. And then I use one stick to get it off of the other stick. There's probably better ways to do this. I'd love to hear the experts' opinion on getting incredibly sticky, syrupy mess on to this here. Okay, so we're just going to take this and sorry, my bad, got a phone call there, and also my timer timed out on me while I was mixing, or while I was trying to get it in, which is not fun. So I got a brand new cup that I'm going to tear out. Okay, and then when I put this guy in, I should know, okay, I've got 2.2 grams in there right now. Okay, we'll get some more in there. This project, the 4-inch to 3-inch 2-stage, is kind of a project for me to at least learn how to use electronics. Not a fan of electronics, and I'm not really an electronics guy, so I want to get some experience on this kind of a rocket where a lot of it is not necessary to have electronics. Okay, we're up to 7.3 grams. Need another spoon here. Again, this is to me the hardest part. Maybe using a syringe of some kind may enhance the ease of working with this stuff. Okay, shoot, 9.5. Okay, I always make sure that I mix as exactly as possible, especially when they call for such, precision measurements. Okay, yeah, so I thought we would go over, so I'm gonna go ahead and pull out. We were at 10.6. Let's see. Okay, and we're at 10.3, so I'm gonna kind of clean off one of these guys. That's why I always do the resin first. It takes, I guess, skill to be able to get it right. Okay, we're at 10.2 now. Remember, we're looking for just exactly 10 grams. That's too much. We're at 9.9 now. Come on. Just want to get the smallest bit off. Okay, now we're at 10 grams. Okay, so now that we're at 10 grams, I'm going to tear it again. Whoops. So that it reads 00. Now we're looking for 2.3 grams of the hardener. I like to use just a clean plastic spoon. It's a clear liquid, and like I said, it's incredibly thin. You can never take out, so always want to put small amounts in. This hardener does have a very strong odor, so be careful if you need to use a respirator or something like that. You may want to do so. 2.2, write it in one drip at a time. and it jumped to 2.4. See if I could take any out. Okay, so that's it. Once we get that, we'll spend some time mixing the epoxy. Again, you can imagine such extremely dissimilar materials don't want to be mixed extremely well. But I'm going to get a new popsicle stick and start mixing this stuff up. Now, once you get it mixed, it works. It's a good consistency, but you want to make sure that you get it, of course, mixed up as thoroughly as possible, or completely thoroughly, I guess. And so then it'll turn into what I would think of as a consistency of regular epoxy, regular hobby epoxy that's been mixed for a while. You don't really have to worry about the pot life for this. It lasts hours and hours. I think I read that it takes about 48 hours to cure once mixed at room temperature. We're going to do an elevated temperature cure at, I don't know exactly what temperature. I may try and pull out a thermometer later after the video once I get it going here. Okay, you want to make sure you get all of the hardener, all of the resin really well mixed. This is not something you want to screw up. I've had uncured epoxy before on stuff, not with this kind, but with other stuff, and it sucks to have to remove all of it and restart. Okay, so now that we got the epoxy mixed, the first thing I'm going to do is get a layer of epoxy onto our tube here. Okay, and again, I'm not worried about going over the lines. This isn't kindergarten. We don't want to learn how to, paint in the lines here. We're more worried about getting the entire surface covered on the airframe, and then the entire surface covered on the fin. We'll put some extra on the fin so that we can sand with it on. Okay, I'm going to move my scale. Okay. And the only thing I did to the fin before I started the video was clean it all with just some rubbing alcohol, just to make that. Okay, so once we got that whole fin surface, or sorry, the whole airframe coated, just kind of want to run a paper towel, make sure there's not any last little tiny bits of anything on there. And then we're going to take our epoxy here, and we are going to put a very generous amount onto the fin. After I do this, I'm going to sand it with 60 grit sandpaper, the same sandpaper you saw me using to sand the airframe. But it has occurred to me that perhaps using a finer grit may allow for better removal of the oxidation layer, which is why we have to do this whole sanding while the epoxy's on deal. I'm not very comfortable with that exactly right now, but I'll do some more research tonight or tomorrow and do that on the third fin probably. But I just want to make sure I do what I know for right now. I'm going to take a fresh piece of the 60 grit sandpaper, and I'm really focusing on getting the entire surface completely etched isn't the right word, that would be chemically etched, which is another option a friend of mine is going to try to experiment with. You want to make sure you keep all the epoxy on. You're not trying to rub the epoxy off of the surface. You're trying to keep the epoxy on while removing the first layer of aluminum oxide, and all the aluminum oxide, I should say. Okay. Again, I kind of like going in circles here. It creates kind of a random pattern rather than one straight edge pattern. Okay. And I probably go back and forth. I guess about 3 times is pretty good. And then what I'll do is, I'm not wiping off. You'll notice there's bits and grits of the aluminum that are in the epoxy, and that's going to be exactly the length we need, the size we need to use to do that. So sometimes I would add some more at this step. We're doing pretty good as far as all the epoxy pretty much stayed on, so looks like we're pretty good. So now what I'm going to do is, I kind of want to be careful here. I don't want to get a whole bunch of epoxy on the fin. But we're going to, on the fin surface, not the root edge, I guess. Okay, gonna put the fin on our line. I'm gonna take off my gloves. I'm not really gonna be touching any more epoxy at the moment, and I kind of want to make sure that the entire surface is again coated, and then I'll find my line that I drew, which is right there. Okay, and I'll find where that fin seats correctly, and make sure again that I'm on my line. Okay, and I'll push down. You'll notice I get epoxy, squeezing out of all the edges. That's good. Okay, all it needs is about a 5/1000th thick epoxy, like web thickness, for maximum bonding strength. Okay, once I do that, I'm going to take some tape, which I have sitting under the rocket, holding it up right now. Okay, I'll take some tape to continually apply pressure during the cure. Oh no, this is old tape. That's okay. And you really want to hold the pressure. Okay. I'll put probably a couple more things of tape on there. The tape really is just to make sure that you don't lose any of the downward force that's holding it. During our N5800 Project 60K, we had an issue when we put it in the curing oven that the tip edge raised about a tenth of an inch, not even that, sorry, about 5/1000ths of an inch, and yeah, that was too much, and it allowed air to get underneath. It was not visible because again that epoxy was built up there, but you really want to make sure that the entire surface is as far down as it can go. And so don't rush this step, because it's very important. Otherwise you will not be happy when your fin comes off it. I don't know how many other guys are going to try going Mach 3 with these fins. I'm excited to see what projects people come up with this new design. I know this rocket's going to have a 54mm motor mount, so it'll take I guess the K, or there's an L2300, the green Cosden motor. That looks like it would be the most intense in 54mm. And should be able to take that no problem. The first flight will probably be for just the sustainer in January. Haven't picked out a motor for that. I'm probably going to keep it low and slow just to kind of get a flight under its belt, be comfortable with the setup of the airframe and the electronics and that kind of stuff. It'll just be the sustainer only while I still machine the 4-inch fins. So okay, so I'm pretty happy with the way everything sits. It's not going anywhere, that's for sure. And so now what we're going to do is we're just going to put it under the curing. If you have a curing oven, great. That'll shorten your time depending on how hot you can go. I'm going to put the tape back under here, just kind of keeps it at a pretty good upright position. Okay, I'm going to put it in my little lighting source area, and when I turn on the lights, I'll try and measure how hot it gets. I left it on for 3 hours for the first set of fins, the first fin, and that took about 3 hours, and it was very, very good. After it cooled down, I'll probably again do the same thing for this one. That's basically it as far as this is concerned. I've gone ahead and used some extra epoxy on a different, this is a minimum diameter Wild thing. And I used JB Weld for the first 2 fins, and then accidentally dropped and broke the third fin off, so I just kind of tacked them on with this high strength epoxy, and it's not really going anywhere. You know, I don't question the JB Weld, but I'm going to probably right now use the remainder of the epoxy to finish some structural fillets underneath the fins. This probably won't see very many high flights. I'm kind of nervous about the inlets in the fins, you know, above Mach or whatever. But definitely will be fun for some 1 or 2 grain I and J motors. And just wanted to do it differently, and now I have an extra 38mm tube and centering rings to go with that. That's everything. I just turn on the light here. Turn on the lights. It gets really hot just because of these just the lights that are in them. That's basically it. That's everything I have to say. If you have any questions, comments, leave a message for me on my YouTube or on the forum. Bandman444 with the aluminum fins tutorial. Thanks.